Dear ladies and gentlemen, I'm going to look at the types of corrosions. My apologies are composted there. And unfortunately, I've not been able to get it as promised. So I have only an example of one. And you guys will look at the rest of the corrosions. So typically, corrosion is classified by the manner in which it manifests or the way it occurs. And this is a function of material environment and surface conditions. Environment play a very important role in corrosion. And there are mainly 8 groups. These are the groups that are there. And in order to be able to select a material, it is important for an engineer to understand the nature of corrosion, type of corrosion, and the method of preventing these different types of corrosion. And this is what you're going to look at in this work. So the example that you're going to look at is uniform corrosion. So uniform corrosion is an electrochemical corrosion that occurs at an equal rate through the surface. So this will not go very deep, it will just be on the surface. And this is affected by the type of environment. Dry atmosphere. So typical dry atmosphere is an atmosphere that will have hydrogen sulfide. Corrosion will take place. Damp atmosphere is a typical case where you have pollutants like sulfur dioxide reacts with the water in the atmosphere and it produces sulfuric acid, and this reacts with the typically your ion to produce iron sulfate. Then we have wet atmosphere. So the wet atmosphere, usually on most materials, there's sodium chloride on the surface. And this will react with the atmosphere until it gets saturated. And this saturation occurs at around 60%. So once saturated, it provides a layer of electrolyte, and this facilitates the corrosion. Then we have acids, as it should be obvious how it affects corrosion. Then we've already spoken about some examples of atmospheric contaminants. Gave an example of sulfur dioxide. And then we have water that contains these hydrogen sulfide, and sodium chloride. These have been seen to promote corrosion. And industrial atmosphere, I think we have already spoken about that. If there are certain chemicals that will facilitate the corrosion, or there are also conditions, for example, water percentage above 60% of affect will facilitate the corrosion. And this is a typical mechanism. You have your iron, and it's oxidized to produce iron 2+, and the causes could be environmental, could be atmosphere, but basically this becomes our uniform corrosion mechanism. And then the remedy. We've already said that this type of corrosion is heavily dependent on the atmosphere. So controlling the atmosphere, if possible, try to exclude certain chemicals, try to make sure that the atmospheric pressure, the moisture in the atmosphere is not above 60%. Then this is based on case studies. So in our example or reference textbook, look at those cases. And we have also a case that we should be aware of, that we should avoid cathodic protection of iron, especially at temperatures above 60 degrees Celsius. This is because at these temperatures, the reaction can be reversed such that the other metal might end up protecting zinc, and therefore your structural integrity will be affected. The another important thing is to use wise material selection. There's an example given there of what happens when you use carbon ion to transport water containing particulates and chlorine. So it is suggested that instead of using iron, we should use PVC. Then the last important thing is that when we are designing our materials, we should always include corrosion allowance. These are our reference textbooks. Number 3, I think is the best for this topic. In this way laid out and laid out the way I've presented here. So make sure that you look at the other types of corrosions that are there. There's no need to memorize the case studies, but get the principles out of those case studies. Thank you.